Hello folks, welcome. This is the final result of what we're going to work here. We can see that we have a regular flip book in one side and we have the pixelated version here on the other side. This is going to be what we're going to be doing. So you can pixelize any texture that you want. This is perfect for retro VFX, and it works really well, works with pretty much any type of textures. So we're going to be using Unity and Amplify Shader Editor. As always, this is version agnostic, pipeline agnostic, and if you know your way around shaders, it's more than likely engine agnostic as well. You can probably make this on Unreal without too much trouble. Let's go, let's begin here. So I'm going to create for me a new shader, and we're going to make it a amplify surface shader, and we're going to call this tutorial pixel. Oops, I wrote a little comma there. All right, so here we have our pixel shader. So I'm using HDRP, so I'm going to change this to be a HDRP unlit shader. So you're going to change this to whatever pipeline you have. If you have standard, that's okay. That's going to work for standard as well. Instead of opaque, I'm going to make it transparent, so we have an alpha channel to work with. We can keep those other settings here at their defaults. I'm not bothered by any of them, and we can save. So now that we have a clean slate to work with, let's begin here by just putting a texture node. This is going to be our main texture, and if we plug this texture into color, emission, and alpha, we're just going to have a simple unlit shader. So we can take a look here at what that looks like. So if I go to my project and I right click and create a material out of this shader, and let me get here my little particle system. This is going to be our tutorial particle system here. So if I go on this guy and I just put our tutorial pixel, we can see here what that looks like. And what I can do is that I can put a smoke flip book here. So we have this one, we have this one. Let's use the same one that we are using for this tutorial so that we keep it aligned, and you can see here what that looks like. So now we have a very simple smoke looping shader, right? Let's turn it pixelized. In order for us to turn this shader into pixels, what we're going to be doing is that we're going to be manipulating the texture coordinates. So if I expand this here, you can see that these are two gradients, right? And what we're going to do is that we're going to essentially scale down this gradient in a way that instead of being smooth, so you can see here that these gradients are very smooth. There's a green gradient that smoothly transitions into yellows, and those yellows smoothly transition into the reds. We want our shader to be staggered, so we want this to be a block of solid green that gets into another block of a slightly less solid green, then a block of yellow, then a block of red, so on and so forth. So that's kind of the idea that we want to apply here to our texture coordinates. In order to do this, we're going to need a resolution. The idea behind this variable, so let's make a property here. We're going to call this resolution, is that these are going to be the number of little blocks that we're going to have on the vertical and on the horizontal axis. So a good default value for this could be 64. So, that's going to be the default resolution. 64 little squares that I mentioned. And what we're going to do here is that the problem is that texture coordinates, there are values that go from 0 to 1. So we got to work on the 0 to 1 range. So what we can do is that if we take a constant value of 1, and if we divide this 1 by our resolution, then what we'll get here is that we're going to get a value that is constricted between 0 and 1, and that we can use on our texture coordinates here. We're going to take here and we're going to split. And the reason why we're splitting this is because we are going to do slightly different operations between the x and the y, and also we want these to be scalar vectors to do such operations. We're going to take this UV here. After all, we're modifying the UV, so we need a reference of the UV. And what we're going to do here is that I'm going to create a panner. And the reason why I'm creating a panner, this is not strictly for the pixelization effect, but it's because it's useful to have a panner so that in the future on our VFX we can make panning noises that also get this effect. So I'm also going to create here a new vector2 variable. By pressing the number 2 and just clicking, you create one when you click. So that's how I create them very quickly. And we're going to call this scrolling. speed. We're going to keep this at 0, and we're just going to plug this into the speed. So you can see here that since the speed is 0, our UVs are kept the same. And now we're going to split this as well. Once again, we want to manipulate these as scalars. Let's begin here. So the first thing we're going to do is that we're going to use a node called fmod. What fmod does is that it returns the remainder of a division between A and B. And if A is positive or negative, this output value will be positive and negative as well. We're going to take our X value from our UV and we're going to plug it into the A, and we're going to divide it by our resolution little block that we created earlier. Then what we're going to do is that we're going to subtract the remainder of this division. We're going to subtract that by the X value. However, we want this X value to be halved. So we're going to essentially subtract half of this little resolution point here. So a way for us to have something is that we can create a new float here. We can call this half, whatever. And the value here, it's going to be a constant. It's going to be 0.5. So we're going to multiply this. So we're essentially, getting this value and multiplying it by 0.5, which then yields half of what it was. And we're going to plug this into the B here for our subtraction. So let me double check here that this is correct. I believe so. And now what we can do is that we can do another subtract. So the result here of this subtraction, we're going to subtract our original X value by this value here. Then we're going to append. Let me get my append vector here. And at this append vector, we're going to click on these little dashes and we're going to put vector 2. And the result for this append is going to go into the X. After all of these operations are being done on the X value. So now for the Y, we're going to do very much the same thing. What we're going to do here is that we're going to take the fmod and we're going to put this on the B and this on the A. We're going to subtract, and the subtraction is going to be the halving of our Y value. And now we're going to subtract this again by our original Y value, and this result can be appended here. So this is going to yield as well a UV. Hooray! But what are we doing here essentially, right? What is this subtraction and multiplication business? Essentially, what we're doing here is that we're doing offsets on the remainder of these multiplications so that our UVs start here at the very bottom. Because if we don't do these subtractions here, then we just offset our UVs as well. So we're going to distort the texture. We don't want to just distort the texture. We want the texture to be pixelated, but their origin points should be unchanged. So this is why we need to have all of those little subtraction shenanigans. Now, what we can do here is that we can plug this into the UV, and one last touch that we can do is that we can take the vertex color and we can multiply our RGBA by our RGBA and put this into the color, this into the emission. We can multiply our alpha, and this can be our alpha here. Now, if I save this, y'all are gonna see the change immediately. It's a very neat shader and not hard at all to reproduce. Let's see here. Okay, my Unity lagged out a little bit, but we can see here what this looks like. We already have our fire being pixelated, and we have the resolution here, so we can make this 9 by 9, for example. Then we just have some squares, which is perhaps not ideal. And we can do like 8 by 8. Okay, that's also not ideal. Let's see if 16 by 16 is a sensible resolution. Not really. One thing actually that we might want to adjust here is that we might want to turn off MIP maps on this shader, which is something that I forgot to do. So what we can do here is that in here we can do MIP mode. Instead of auto, we can put MIP level, and we can keep this at 0. And we can also enable here no scale and offset, which means that there won't be an option on the editor here of this texture for us to do scale and offset. And you can see in here that before we had some little pixels kind of hovering about, and now they are gone. Let's see if 32 by 32 we can, okay. You can see a little bit more of the constitution, but this texture here worked best with 64 resolution, worked really well. And yeah, and this is texture agnostic, so you can try to put here other textures and you can see that this works. This is a lighting texture. You can put pretty much anything in there and it's just gonna work. So yeah, it's a really cool trick and I hope you guys enjoyed it. Thank you so much for watching. Do not forget to like and subscribe because it keeps us going.